This is the third video in the series about shell programming. Much of this video is about some other control constructs in SH which don't involve process exit status. This video is not meant to be understandable until you've already understood the previous two videos. But first I want to talk about quoting in SH. In normal programming languages, a string needs quotes, most commonly double quotes. If we want to run the ls command on two directories from our C program, we're going to write something like this. That's pretty cumbersome, especially as compared to the command in SH. Where the $sign is the shell prompt, we just write ls dir1 dir2. We really wouldn't want to have to write this as the shell prompt, although you could argue that we should because all three of these are strings, but we really don't want SH to work that way. In C or Java or Python, there's a big difference between ls with the quotes or without the quotes. With the quotes, it's a string. Without the quotes, it's a reference to some existing variable or function or something named ls. However, in SH, these will be the same. They're both strings. Everything's a string. So how do we make this work? We use a dramatically different tactic than in a normal programming language. In a normal programming language, when you write something like ls, the programming language processor interprets it. It figures out, is this a keyword, variable, function name, whatever. But in SH, the shell will interpret only some things. If we write ls, that's a string. If we wanted it to be interpreted as a variable name, then we would preface it with a $sign. This is a good compromise for something which is both a programming language and the way we type commands daily, but it has some odd consequences. It means we have to have a way to suppress the special interpretation of interesting characters. How do we use the echo command to output an actual greater than symbol? Suppose we want to do something like this Python program. Okay, that wraps around on this unusually narrow display in this video, so I'm going to truncate it for this video. In SH, we can't just type this. What happened to the output? It went into the file .forward. So we need to quote this to suppress the special meaning of the greater than symbol. As a matter of fact, there are three possible ways to quote this. First of all, we can use a backslash to suppress the special meaning of a single following character. Or we can use single quotes. Or we can use double quotes. Single and double quotes have different semantics, but we need a more involved example to illustrate. Let's customize the example address for the user. Suppose we have it in a variable. Okay, it went into the .forward file. We need some quoting to make this work. That's too much quoting. We want the special meaning of $sign to be honored, but the special meaning of greater than to be suppressed. And double quotes do exactly that, with some wraparound. They suppress everything except for $sign, back quote, backslash, and the closing double quote. Whereas single quotes suppress more, everything except for the closing single quote. So both single and double quotes suppress the special meaning of a space. This is a bit subtle, but if we go back to the terminal window, we see that this double space was collapsed to a single space in the output here, but was preserved when quoted. That's because in this command, the first argument to echo is just FWD, second argument is 2, the third argument is user host, and so on. Whereas in this command, there is only one argument to echo, which is this string, forward to user host, type echo user host directout.forward. In any case, echo outputs all of its arguments separated by spaces, so the result is very similar. But compare In the second case, the file name is actually the 3 characters A space B. That 3-character string is all one argument to cat. So space is also a special character to the shell, and its special meaning is also suppressed by quoting. Suppose we have a file named Hello World with a space in the file name. We might have a variable containing this file name. If we wanted to cat the file normally, we couldn't do cat space hello space world because of course cat would get 2 arguments, neither of which is the actual file name. Instead, as we now know, we have to use quotes. Similarly, if we want to use the variable, we can't write cat space $filename because the shell interpolates the variable value, then takes the spaces as separating arguments. But again, single quotes suppress too much, so we want double quotes. The double quotes suppress the interpretation of the space, but they don't suppress the interpretation of the $sign. So almost any time we have a variable whose value might include a space, we are going to want to put the variable interpolation in double quotes. Okay, let's talk about more control constructs. The for construct is more like the one in Python than the one in C or Java. The for loops over any number of strings. Of course, you don't always specify the list of strings literally. Here we loop over all file names ending with .c. The seq command is a useful tool which outputs a range of numbers based on its arguments, very similar to range in Python. This is very useful in a for statement in back quotes. If we write for I in back quote seq14, then it will run seq. seq's output will be captured. The output will be substituted in the command line, so this will be the same as writing for I in 1, 2, 3, 4. But that's more boring, so let's go back to this. Let's add the numbers from 1 to 100. Sum equals sum plus I. We haven't talked about processing the command line arguments to your shell script yet, but I will mention at this point that there is a version of the for statement which loops through all of the command line arguments. You write for and a variable name, and that's all. With no arguments, the loop executes 0 times. sh also has a case statement. In case you were starting to miss the reversed keyword for the end keyword, here's another one in the case command. The syntax is pretty weird with the closing parentheses in the case labels. It's meant to look like numbered items in traditional text, in which we use a right parenthesis in this way. But in a programming language it's weird, but not really problematic. In case you haven't seen case or switch in other programming languages before, it's similar to a cascading if, else if, except that there's one value being compared always. Each case compares it to a new fixed string. So if $i expands to hello, we execute the first case, else if it expands to goodbye, we execute the second case. Each particular case is terminated with a double semicolon. Programming languages with case statements generally have the possibility of a default case, which is executed if none of the fixed labels matches, like the else at the end of a cascading if, else if, else if. In sh, we have a more general mechanism, which is that each of the case labels is actually in the glob notation, the pattern language used for file name wildcards. So for a default case, we can use an asterisk, like here, which matches anything because the case labels are tested in order. So it's only going to check the asterisk against the value of $I after hello and goodbye don't match. And it is a loop for I. Here's that file again. You can pause the video if you want to look at it. Let's have a little look at other uses of the glob notation in case labels. Change hello to hello star. Now compare the behavior of the old version to the new version. Again, please pause the video if you want to look at this more. That concludes the third video. The fourth video in this series is about I/O redirection and about command line arguments.